Hello and welcome back to BME 2315. Today we'll just be looking at some very basics of Python to give you an idea of what you'll be working with again, and also as a refresher for your past computer science course. So I've started Spider, which is the development environment that I'll be working with. You're free to use a different environment, but I'm probably only going to be able to help you with the development environment that I'm most familiar with, which is Spider. So let's look around at the screen first off. You see up in the top here is listing what's called the working directory, which is the directory that we can currently access and pull files from. So you want to set this to be the place where your Python files are stored for now. Below this window we have our editor, which is where we'll be editing code. And so right now I've got pulled up this Python basics, but when you first load this, it'll usually have an untitled empty Python file for you right now. And then there are also a few other tabs that are really nice. One of them, if you need to manipulate what directory you're in, you can go to the Files tab. There's a Plots tab that we aren't using quite yet. There's a Help feature, which can help you find help. Mention that. You just type in the name of commands and it'll pull up some documentation for you. And then let's go back to the editor. And then finally there's the console, which is where we can interactively input commands. So for example, we can say x equals 5 and see that that variable is 5. The next thing that you want to know is, in addition to the console, Spider has a very nice variable explorer, and that allows us to look at the values of those variables. So if we open that up, we see that it has stored x right here. It is of type integer and of size 1, and the value is right here. That's going to be a very useful feature for us to tell what values are stored in our variables. So let's now go back to the console and back to Python basics to look at some of the basics. So first off, there's basic arithmetic, such as x equals 5. I already did that one. You can raise things to powers, which is 2 stars, like this. So we can see that y is 4 now. Or division, all the basic arithmetic that you're used to seeing. We can create strings using either single or double quotes. So for example, if I say my string equals this is my string, okay, and then I can print that back to the user like this. So it says this is my string. So those are some of the very basics. One thing that's really nice about Spider is that it has a cell mode similar to MATLAB in that it breaks code into sections if you use this special commenting mark. So a pound sign right here is for just any comment, but if you follow that by 2%, that creates code sections, and we can run one section at a time. So if you look at the top, this play button is for playing an entire file, but this next one is just running the current cell. So if I click that, it runs just that cell, and we can look at the variable explorer, and we can see that x, y, and z were created. So that can be really useful. So then if I click down here to the next cell and run this cell, and then it says here's my string, it is a nice string. That's nice. So the next thing we should look at are some of the very basic control structures, and one of the most basic of these is the if then else structure that we have in computer programming. In Python, we've got if, it doesn't make you write then. We've got an else, and in between here is elif, which is a condensed form of just saying else if. So basically right here we're doing these comparisons, and if I run just this cell, it says okay, because it failed on this first one, it failed on the second, and so it went to the else statement. If instead we flip this around, well, we don't even need to flip this around. Oops. flip this around. This is not okay. All right, so that's the basics of a if-then-else structure. Now let's go to loops. So one of the most basic loops is a for loop. And so notice here we say for I, that's our counter, in range 0 to 4. So it is creating the list of index values that it'll try. It'll say print and then the value of the counter. And notice in print statements you can have strings that are separated by commas like this. So if we run this, we get counter equals 0 through 3. So that's a for loop. The next one we'll look at is a nested for loop. And so in this case, we're looping over both I and j. And so it's going to be a little bit more challenging to code this without errors, but regardless, this is working code right now. And so it's going to go update I, and then it's going to update all the j's, 0 through 4, and then go back to update I again. And so we're going to be able to see that when we print the output of this counter. Like this. See how it went 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1, 1, 2, like that. So that's a nested for loop. Next, let's look at a while loop. We use while loops when we don't know how many times we want to run it, and we want to keep running it until it reaches a certain criterion. In this case, we just did the most basic and said 5, but in general, a lot of times in a while loop, we'll use that if there's something inside the computations here that are used to determine whether we should continue or not. But in this case, we'll run this while loop and see it can count 0 through 4, as we expect. So those are all the most basic control structures. Now let's look at some of the conditional expressions. So we use conditional expressions when we want to do comparisons. And so we use a double equal sign when we want to say equal. And we got less than and then equal if we want to say less than or equal. And exclamation point equal if we want to say not equal. So let's do a couple of these at the command line. So I right now is 5. So if I go I equals 5, that's true. I equals 4 is false. I can say I not equal to 5, which is false because we know that they're equal. And then you can also combine logical statements. Like if we say I equals 5 and I less than 7, right? So I think that will be true, right? But if we say I less than 3, then that's going to fail. Or we can use an or statement and say I equals 5 or I less than 7, or I had it as 3. That would be true. Okay, so the next and final topic I'd like to cover in this little video is creating functions. So Python makes it really easy to do so. So in the function definition, you're going to say def, and then you have the name of the function. Then you have two input arguments, in this case, A and B. And then there's an indentation right here that's important. And we're going to create a new variable C, which is the sum of these two. And then we're going to return C to the user so that someone can then run. Actually, let me run this code to make sure that's in memory. And then now we can use this function. So we say add two numbers 2 and 3, and so 5. Or we could say C equals add two numbers 2 and 3, and the value of C is 5. Or sometimes we'll find that we need to, for compactness, define a function on a single line. Oops. And so we can do it this way. It's still the same syntax, really, as def, and the name of the function, return A times B. So let me just kind of show you that that can be convenient when you want to define a function at the console. Like that. So I defined an entire function right there, and now I can say multiply two numbers, say 3 and 4. and gives us 12. So those are some of the basics that you'll be dealing with in Python, and I hope that's helpful for you, and I'll see you next time.